Good morning, all of you MSc Physics second year student. So today we want to see our subject is energy study first semester third, and we want to continue our third chapter, which is basic of heat transfer. So summary of the last lecture we have to see here that the points which is considered for the basic units of different physical quantity and the terms which is defined here, what is meant by the thermal energy or what is meant by the heat and what is meant by the enthalpy, and depends upon the internal energy, that the first law of thermodynamics. So that energy or internal energy which is depends upon or which is based upon the adding the heat of the system and work done of the system, so that E is equal to Q plus W. And after that we have to see here the enthalpy, that is nothing but the measure of the energy content in the system per unit mass, and already we have two relation about this. In this lecture we want to see next point of this system, which is considered as the entropy, or what is meant by entropy. So that entropy is nothing but the measure of amount of energy to available for to useful work in the system, that is known as the entropy. And that entropy, which is denoted by the symbol which is delta S, and which is given as the unit which is given as the joule per kg or kilojoule per kg degree Kelvin. So that is the idea of the entropy, and that is useful to calculate or to measure how much amount of energy which is present in the system or the component which is we have to doing the work. So that is entropy, which means that a thermodynamics measure of a thermodynamics measure of the amount of energy available, the amount of energy available for useful work in a system, for useful work in a system So that terms which is considered as that undergoing the changes, system undergoing the changes, this term which is nothing but at the entropy. If we see that the measure of the degree of the disorder of the substance, so that is the system of entropy which is always increases, and which is available energy which is considered as the always decreases. So that is the depends upon the system or to different system, what is the change in entropy, that is what is the change in the energy, that energy is increase or decrease. So that is the depends upon the change in entropy, and that symbol for entropy which is considered as the capital S or delta S. So that is given here, that the symbol of entropy which is given as S, or which is considered as the change in entropy, that is the delta S. And given the SI unit which is given as the entropy, which is considered as that kilojoule per kg into degree Kelvin. So that kg into degree Kelvin. So that is the units of the entropy. And if we see that consider the equation of the entropy, which is considered as that is the depends upon the specific entropy which is based on the either unit mass or either unit molar quantity of the system. So that is the specific entropy. We have to given here the consider the idea of the equation of the entropy. So that is the equation of the entropy which is based on the specific entropies. Specific entropy is based on either unit mass, based on either unit mass, or which is considered as the unit molar quantity of the system, or unit molar quantity of the system, and if we see that the equation for the thermodynamics process of entropy, so that is considered as here. So for thermodynamics process, the equation of entropy which is given as here. So process of a system, so that relation will be come here. So that is given as that delta S is equal to S2 minus S1. So that delta S is equal to S2 minus S1. So that is the change in entropy of the system. So that is first system to second system, that is change in entropy, and that is given by, which is depends upon the change in heat with respect to temperature of the system. So that is considered as the integration for system 1 to system 2, that is dq, that is change in heat with respect to temperature. So change in heat with respect to temperature, that is dq by dt, or which is considered as, we have to say that, the reversible process. Okay, so that is the idea about the entropy. Now next concept we want to see here. So that is very main concept which is given as the chapter which is basic of the heat transfer, or concept of the thermodynamics, which is given as here the temperature. The main point which is given as the temperature is there. So what is mean by temperature? We have to see here what is mean by temperature, or what is the sense of the temperature, that we have to analyze, or that is the understanding the idea the temperature. So that is the degree of hotness or coldness of a body, that degree of hotness or coldness of a body, and that is the degree of heat which is compared to the surroundings. So that is known as the temperature, or a measure of hotness or coldness of a body for standard temperature scale. And temperature, which is considered as, is an independent basic dimension which cannot be described in terms of the mass, length, or the time. So that is temperature which is does not depends upon the what is the mass of the substance, what is the length of the substance, or what is time. So that is the independent quantity of above this configuration. So that's why we have to say that temperature which is considered as the only depends upon the degree of hotness or coldness of a body. So we have to write here a degree of hotness or coldness of a body, a degree of hotness or coldness of a body, or that is which is considered as a degree of heat compared to the surroundings, or a degree of degree of heat as compared to surroundings, as compared to surroundings, as compared to surroundings. So that is known as the temperature of a body. Or if we consider that a measure of hotness or coldness of a body on the standard temperature scale, or we have to another consider as a degree of hotness, hotness or coldness, or coldness of a body, of a body at of a body on standard temperature scale, on standard temperature, on standard temperature scale. So this is known as the temperature of a body. And temperature which is considered as it is independent of the dimension, which cannot be described, which cannot be described on the basis of the, on the basis of the mass, length or time of a system. So now next concept we want to see here, so that is the specific heat. But if we see in this temperature system, so that is the standard SI unit of the system, or symbol of the system which is considered here. So that is the SI scale, which is the temperature which is measured in the Kelvin, or that is given as the absolute scale in terms of the Kelvin, or corresponding to the particle or practical scale which is considered as the degree Celsius. So that is the unit of the measurement of the symbol which is given here. So that units of temperature, units of temperature, or first of all we have to see here that symbol of temperature, symbol of temperature which is given here, that capital T or small t, or we have to given that units of temperature, units of temperature which is given here. So first of all Kelvin or degree Kelvin, and that is denoted by the capital K. So that is the SI units of the temperature. Or second unit which is given as the Celsius, or which is denoted by the degree Celsius. So this is the unit of the temperature. Now next point we want to see here, what is mean by the specific heat capacity. What is mean by the specific heat capacity? Specific heat capacity, specific heat capacity of the body. So that specific heat capacity means that that is the amount of the heat required for changing temperature of unit mass of the material through 1 degree of the temperature, through 1 degree of the temperature. So that is known as the specific heat of capacity, and that unit of specific heat capacity is joule per kg into degree Celsius. So that is the amount of heat required, the amount of heat required, amount of heat required for changing temperature, for changing, for changing temperature, for changing temperature of unit mass of the material, of unit mass of the material, mass of the unit mass of the material through 1 degree temperature. Through 1 degree Celsius temperature, or which is considered as through 1 degree temperature, 1 degree temperature, and that is known as the specific heat capacity, that is known as the specific heat capacity, and that unit which is nothing but the joule per kg into degree Celsius, joule per kg into degree Celsius. So this is the term, or this term which is considered as the specific heat capacity, that is the amount of the heat which is required for changing temperature of unit mass of the material through 1 degree temperature, and that unit which is nothing but the joule per kg into degree Celsius, Now next concept which is given as here, that what is mean by the heat of the fusion, what is mean by the heat of fusion, and that is depends upon the fusion capacity of the material, or which is known as the that amount of the heat required for melting unit of mass of the material, that is known as the heat of fusion or specific. So now next concept which is given as the heat of fusion, or which is considered as the specific heat of fusion, or that is known as the amount of heat required, the amount of heat, required, for melting unit mass, for melting unit mass of the material, and this is known as the heat unit of fusion or specific heat of fusion, and that unit also which is given as the joule per kg, so that is the terms of the heat of fusion. Now next which is given as the heat of evaporation and vaporization. Next concept that is given as the heat of evaporation, or which is considered as the vaporization, of the specific heat of evaporation or vaporization, and that concept which is nothing but that of amount of heat which is required to vaporize unit mass of the material, the amount of heat required, the amount of heat required to vaporize unit mass, of the material, this is known as the heat of vaporization or evaporation, so that the amount of heat which is required to vaporize the unit mass of the material, and again that unit which is considered as the joule per kg. Okay, that unit which is considered as the joule per kg. Now next point which is given as what is meant by the intensive properties of the material. Intensive properties of material and next one which is considered as next property which is considered as the extensive properties of material. Extensive properties of material. So what is meant by the intensive properties of material, or what is meant by the extensive property of material? So that intensive property of material which is given as the characteristics of substance which can be specified in terms of the per unit, which is in terms of the per unit. So that properties of material which is in terms of per unit, that is means by if we consider example of this pressure, and that pressure which is considered as the per centimeter square, or electric potential which is given as the work per unit charge. So that type of property which is considered as the intensive property of material, and extensive property of material which is considered as the properties which is given as a system. For consider the whole property of the system, that is given as the volume, conductivity, or efficiency of the material. So that type of the property which is considered as the extensive property of material. For next lecture we have to see here the first law of thermodynamics, second law of thermodynamics, and zeroth law of thermodynamics, and what is the another concept that will be seen in the next lecture.